Hi, good morning. Can you hear me?
Good. Yes, I can hear you.
Okay, so how are you?
I'm good. How about you?
Alhamdulillah, I'm fine. Thank you. So basically, okay, so I simply share my screen, then try to discuss about your problem.
Mm, okay.
So can you see my screen now?
Not yet.
Uh, Okay. So
Yeah. Yeah.
basically, I did not access your shape file. Okay. So you can simply access
Okay.
me, then I can easily access the code in here. Okay. So you can simply share the
Okay.
script. So how you can easily share this? You can simply go to the asset tab, and then you can share.
Mm-hmm.
Simply click to this your shape file. Simply click to the share, and after this you can simply click on the anyone can read. Anyone can read. Then click to the done, then I can easily access the your boundary area. Okay, so you can do this, then I also check the code. Okay.
Okay. Oh. Oh. I'm trying to connect my.
So you can simply share this, then I can simply run this code, then I can easily this code will be executed, and we did not get the any error. In this time you can see it showing that there is the no collection or not found. It's not found. Okay. So when you share this, then I can easily find
Okay.
out this area.
Okay. Let me try. We are still in lockdown and I'm trying to use my computer at the office, so I have to also join in with that one so that I can share. Okay.
So
You said I can go to asset.
yeah, so if you have, you can simply share your screen. Then I also guide you how to share this. No problem. So you can simply share your screen. Then go to the Art Engine code editor. Then I can simply share you that what's the process, so that I can easily access your shape file or boundary shape file.
Okay. I can add your email because I want to share you my boundaries.
Okay, so did you get this?
I have to put your email to that one.
So you can simply open your code editor. Then you can simply go to your asset tab. Okay, so you can simply find your
Mm-hmm.
shape file, which asset you want to uploaded, which name are used for uploading your shapefile. Simply click on this and then simply share it, then it will be okay. So I can easily access this code, access your
Okay,
shapefile,
okay,
boundary
okay.
shapefile.
Oh my gosh.
Now it's okay. Yeah, so now it's done. Okay, so I can access your
Okay,
shapefile and now I can get the code. There is the no error. Okay, so
okay.
basically you want to know about that NDBI. Okay, so NDVI is that normalized difference build up index, and this formula, this is the actual formula of NDVI index. So basically this is the short wave infrared band and near infrared band. We need the two kind of band, short wave infrared band and near infrared band. So this is our formula: short wave infrared minus near infrared divided by short wave infrared plus near infrared. So you can use any satellite image, no problem. It can be Landsat, Sentinel, no problem. But you have to find out what is the short wave infrared name in Landsat image, as well as what is the short wave infrared name in Sentinel image. Okay, so in this time here you can see this is one kind of article, so you can also try to check this article, then you can easily find out all of the details about the all of the index, normalized different index as well as NDVI index. So basically this NDVI index is that short wave infrared minus near infrared divided by short wave infrared plus near infrared. When you are using the Landsat 7 image, Landsat 7, then your formula is that band 5, because Landsat 7, band 5 in Landsat 7, band 5 is represented the short wave infrared band. Band 5 is the short wave infrared band and band 4 is the near infrared band. Okay. But when you want to use the Landsat 8 image, you can see Landsat 8 image, then your formula is that band 6 minus band 5, because in Landsat 8 image, band 6 is the short wave infrared band and band 5 is the near infrared band. Just it. Okay. And now what we can get from this, we can get from the normalized difference index values between -1 to +1, and negative value of NDVI represented the water bodies, whereas higher values represented the build-up areas. So higher positive value, it's identify the build-up area. Okay, and NDBI value for vegetation is very low, or we can say that it's the negative pixel value. Okay, so in this time we are using the one, suppose I want to use the Landsat 8 image and try to calculate the NDVI in this code for your region. Okay, So for this, okay, so I use the new code editor. Okay, no problem. So I just simply write the code from here. Suppose, okay, so I simply all of the things I commenting. So it in this time it not executed, and then I simply write the code again. So first of all, I need to suppose I want to calculate the NDVI for year of 2021 like this. Okay, 2021. So for this, I simply go to the browse data catalog and then I find out my image collection. So I want to use here the Landsat images. So I simply click on the Landsat, and I want to use here the Landsat 8. This type of image collection I want to use. So I want to use here the top of atmospheric image collection. Okay. Then I just simply copy this image ID from here because I want to use this image collection. I simply copy and then simply paste in my code editor. So I just simply take a variable and give the variable name is the L8, and then I simply paste my image collection ID. So now you can see I just simply put this image collection ID, and now I want to filter this image collection. So I just simply take the variable name is the image, and then I simply call the L8, okay, and then I simply use here the filter bounds function. So it intersecting with my whole collection. Okay, so then filter bounds with my shapefile. My shapefile variable name is the table. So I simply copy and then simply paste here. Okay. In this time, I need to also add here the another thing is that I simply use here the filter date function because I want to calculate the NDVI for year of 2021. Suppose 2021. So I simply put here the 2021 1st January from 2021 December 31. Okay, so I simply take my date, filter date function. After this, I also need to filter the image properties. I simply use here the filter metadata, and then I simply filter metadata. I just simply use here the cloud cover, then less than, suppose I want to need only for this image, which image is less than 1% cloud cover. So I simply use there the 1, okay, for your region. In this time, I simply check my result, how many images available for your region, which image is the less than 1% cloud cover, how many images available, I have to check it. I simply print this image, and then I simply use there the size function, and then click the run. So now it's showing the result, how many images is available for your region, which image is the less than 1% cloud cover. You can see I can get total 3 images. I can get the total 3 images. These 3 images is the less than 1% cloud cover is available for your region. In this time, I want to create all of the images. I want to create the median pixel value of all of the images. I simply use here the median function, and then I simply clip with my shapefile table. Okay, and then I just simply show the result. So for this, I simply use here the map.add layer, and then I simply call this image and click the run. So now you can see it will be added the layer of the satellite image for year of 2021, and this image is that less than 1% cloud cover. So you can check it. It will be cover or not your region. So your region, will check it. Just a minute. See. Okay, so I think some part is not available in here. So I also add the layer for your shapefile. Then we can easily understand. So I simply use the map.add layer, and I simply call the object is the table. So now you can see I can get the also the another layer for your shapefile in here. So this is your image. Okay, and this is our full area. Okay, it means that your region, this region which I cannot find out the satellite image, it means that there is the no satellite image for Landsat which image is the less than 1% cloud cover. So in this region, 1% less than 1% cloud cover image is not available in this region, but in this part is available from this part. So that's why I can get the satellite image in here. Less than 1% satellite image is available, but in this part there is a no satellite image available which are less than 1% cloud cover. Okay, so that's why I did not find in here. So in this time I just simply increase the value. I need the, suppose I use here the suppose 5%, then click to the run. So now I can see the 5% is the complete my region or not. I want to check it. Okay. I think now it completed region. Okay, so now it's almost completed our fully region. Okay, and in this time, suppose I want to add the visualization, so I just simply use add the true color composite. So I just simply use add the B4, B3 and B2 true color composite 98%, and click to the apply. So now I can get the satellite images in here. So I can get the satellite images in here. So this is my satellite image. In this I simply import this. I just simply import. You can see it will import it. I simply copy this and then I simply paste after the object name. In this time, object name. In this time, you can see if you want to check how many band is available in the satellite images, I select the B4, B3 and B2 band. So that's why I can get the true color composite. Okay, so in this time I want to check how many bands are available in here. So I simply print this image. So now I can get all of the information about this image. You can see in here. Here I can get total 17 bands. You can see B1, B2, B3, B5, all of the band I want to get. Okay, and all of the band is stored in a variable. This variable name is the image. Okay, in this time I don't need for all band. I need only for my specific band. I need only for the short wave infrared band as well as near infrared band. Only for the two band, because I want to calculate the NDVI. I don't need all band. I need only for the two band. This band and this band. So in this time I can simply go to here and find out the two band. Short wave infrared band. This is my short wave infrared band. So B6. This is the B6 and near infrared band. And this is the B5. Okay. And it is the Landsat image. You can see short wave infrared band is the B6 and near infrared band is the B5 for Landsat 8. But when you want to check the Landsat 7, then you can get the another band, because Landsat 7 you can see I also show you that for Landsat 8 band 6 and band 5 is okay, but for the Landsat 7 it will be band 5, because for the Landsat 7 B5 is represented the short wave infrared band and band 4 is represented the near infrared band. So that's why when you want to use the Landsat 7 image, then we need to change the formula. So in this time I use here the Landsat 8. So I just simply use here this band. So for this I simply go to the code editor and then I just simply take a variable. Suppose I give the variable name is that suppose short wave infrared. Okay, then I just simply call this image. Okay, I call the image because this image is stored total 17 bands. From the 17 bands I want to select only for the one band. So I just simply use there the select my one band. What is the band? I want to select the short wave infrared band. And what is the name? You can see the short wave infrared band. This name is that B6. So I just simply copy the B6 and then I simply paste here. So now it's okay. I simply paste here. In this time, I also need to select the another band, near infrared band. So I just simply use here take the another variable and give the variable name is the NIR. You can use any variable, no problem. And then I simply use here the image, and then I simply use here the select function, and then I simply use here the what is the near infrared band name. You can see near infrared band name is that B5. So I just simply copy the B5 and then I simply paste here. Okay, so I simply select my two band because I want to calculate the NDBI. Okay, so in this time I want to just write my formula. So my formula is that you can see my formula is the NDBI NDBI build up index is that I want to need the B6 minus B5, okay, then divided by B6 plus B5. Okay, so this is my formula. In this time I simply take a variable and give the variable name is that NDBI, and then I simply use here I simply call the short wave infrared this variable, because this variable is stored in my band B6. Okay, I simply paste here, and then I simply use here the subtract function, and then I simply call the near infrared band, subtract with near infrared band. I simply paste here, and then I simply use here the divide function, divide with short wave infrared. Then I simply use here the add with near infrared. Okay, so now this is my formula I simply put. So in this time I just simply show the result NDVI. So I simply use here the map dot add layer, and then I simply call this object NDVI and click to run. So now it's showing the result of NDVI, or normalized difference built up index. Okay, so you can see it added another layer, and I did not add any visualization, so that's why it looked like as a ash color map here. So now you can see here it will be appearing. So now I can see here. So now I can see. Okay, so now this result is appearing in here. Okay, but I did not add any visualization, so that's why it looked like this. So you can see. Okay, so this is our map for NDVI. Okay, so it looked like this because I did not add the visualization. So in this time I add the visualization and try to find out the build up area, or if you want you can simply export this map as a TIFF format, and when you want to open this map in ArcMap software you can simply add here the different types of color as a build up area. You can use here the red color as a in this time the higher NDVI value. So just a minute, I take the call, then continue. I have an important call. Just a minute. Okay, so now you can see I want to add here the visualization. Then, so for this, we already know about that. For the higher NDVI value or positive NDVI value is represented the build up area, and the lower NDVI value, it can be vegetation or water or rocks, this type. So I want to just make a visualization parameter in here. So for this, I simply take a variable and give the variable name is the suppose DIS. You can use any variable name. I can simply use here the curly bracket. In this time I simply use here the mean. Suppose it will be start from the -1 pixel value and max up to +1 pixel value. And I also want to add here the color plated as a make a list. In this time I want to show which pixel value is negative or very low. I want to show the result as a suppose green color. Okay, and greater than green color I want to show the result suppose yellow color, and I also want to show greater than yellow color I want to show all of the pixel value as a red color. I simply use there the red. Okay, then I simply just copy this visualization variable name and then paste after the object name. So I simply paste the object name in here and then click to the run. So now you can see I want to get the colorful map in here, and then finally I can simply download this map as a TIFF format and work with the ArcMap software for making the map for our research paper as well as presentation work. Okay, so basically this is the things when you want to calculate any index. You can just follow the process. Then I hope you can easily calculate any index. It can be NDVI, NDWI, SAVI, or any other types of index. You can easily calculate it in here. You can see in this time the green pixel value. I want to get the some green pixel value. It can be vegetation or it can be water, but where I can find out the red pixel value. Suppose you can see some red. I want to find in here some red color pixel value. So it can be build up area. Also you can see build up area. Okay, so you can see the water. Okay, so in this time this is our NDVI map, and you can simply download this map as a TIFF format. Okay, so now I will try to show you that how you can easily download the map as a TIFF format, and then you can use the ArcMap software for make the other details. Okay, so basically this is the fundamental part I try to discuss about that. You can follow the process. You can calculate it any index. Just we need to you can simply import your image collection. It can be Landsat or Sentinel. Then you can find out your formula. What is the formula? You find out. Then you can simply when you want to find out the formula, you can choose the band. Okay, you can see in this time NDBI we need the short wave infrared band and near infrared band, two type of band. So you need to select the two band. Okay, then you can simply just write the formula and then you can get the result of this index. Okay, then you can simply download this image and then you can easily make the map for your research paper or presentation work. Then it will be okay, done. So in this time, suppose you want to work for the Landsat 7. So you can simply go to the Landsat 7 image. So I can simply go to the Landsat 7 image. So you can see, I can simply open the Landsat 7 image. So I want to use the Landsat 7 ETM plus sensor. So I want to use the same atmospheric. So that all of the things will be same. You can see this image is available between this time period. Okay, so long time period you can get this satellite image. So between this any time period you can calculate it any index from this using the satellite image. This satellite image availability date is time here. So you can simply copy this and paste here. The same process, and you need to find out your band. So for the NDVI we need to use here the short wave infrared band and near infrared band. In this time it will be B5 and B4 because my short wave infrared band is the B5 and near infrared band is the B4. So you can simply select this and calculate the NDVI using this satellite images and the same process. So in this time, if you have any question or any doubt, you can ask me. Any question in here for the calculation?
Okay, I have one question.
Yeah.
Maybe you can go back to the result, the image.
Okay. So basically, we are using the any types of satellite image using this formula, and we can easily get this result. And final product, we need to export this map. So I also try to show you that how you can easily export this map and work with the ArcMap software. Okay. And basically, this is the formula. This is the method when you want to calculate any index. Okay. So this is the method. We can using this method we can easily calculate any index, and then we can make the map using the ArcMap software for our research paper as well as presentation work. So in this time, I shall try to show you that how you can easily export this map and work with the ArcMap software. So for this,